In this week's homework assignment, the first three problems are asking you to do a two-sample t-test. A two-sample t-test is used to decide if there's a difference between the means of two populations. Here I just took one of the problems from your homework and changed the situation. In this problem, I'm trying to decide if the mean height of San Jose is different than the mean height of Redwood City. I've taken a random sample of 30 people from San Jose, and I've taken a random sample of 30 people from Redwood City. I've recorded the heights of the 30 people in the San Jose sample, and I've recorded the heights of the 30 people in the Redwood City sample. Also, I've used the data to calculate the mean height of the San Jose sample and the mean height of the Redwood City sample. X bar 1 is the mean of sample 1, X bar 2 is the mean of sample 2. I've also used the data to calculate the standard deviation of the San Jose sample and the standard deviation of the Redwood City sample. In each of these three problems in your homework, the first question says to write out the null hypothesis and the alternative hypothesis. In a two-sample t-test, the null hypothesis is the possibility that the population means are equal. And the symbol for the null hypothesis is H0. So in this specific problem, the null hypothesis would be the possibility that the mean height of San Jose is equal to the mean height of Redwood City. I'll say San Jose population just to make it clear that I'm talking about the mean of the population and not the mean of the sample. And the alternative hypothesis, which is H1, is the opposite possibility. It's a possibility that the population means aren't equal. So I'm going to write it out the same way, but I'm going to change equal to not equal. So in a two-sample t-test, the null hypothesis H0 says that the population means are equal. The alternative hypothesis H1 says that the population means are not equal. And I've just written them out so that they fit my specific problem. Once you've written out the null and alternative hypothesis, the competing possibilities, the next part of the question says to calculate the t-score. This is the formula for the t-score in a two-sample t-test. This is the mean of sample 1, the mean of sample 2. This is the standard deviation of sample 1 squared. You actually have to square the standard deviation. This is N1, the mean, or the size of sample 1, the first sample size. This is S2, standard deviation of sample 2. That actually also is squared. And N2 is the size of sample 2, or the number of people in sample 2. So on the top of the fraction we have the mean of sample 1 minus the mean of sample 2. On the bottom of the fraction, everything is under a square root sign, under one big radical, and we have standard deviation 1 squared, standard deviation 2 squared. We have the size of sample 1 and the size of sample 2. So we're going to plug everything into this formula. So x bar 1, that's the mean of sample 1. That's 72.3. X bar 2 is 65.4. That's the top of the fraction. Now we have to plug in the first standard deviation, S1, which goes right here. And we have to square it, so it's actually 3 squared. Underneath, for N1, we put the size of sample 1. There's 30 people in the sample 1 from San Jose, so it's 30. Here we have S2, the second standard deviation, which is 4. It has to be squared. Underneath, we have the size of sample 2. There's 30 people in the Redwood City sample, so it's 30. Next, we need to square the standard deviations. So 3 squared, 3 times 3 is 9. 4 squared, which is 4 times 4, is 16. Next, we're going to add the fractions. The fractions have the same denominator, so we can just add 9 plus 16, which comes out to 25. So since 9 plus 16 is 25, we now have 25 over 30. Under the radical. Now we're going to divide 25 by 30 so that we have one number under the radical. Comes out to 0.83. Now we're going to take the square root of 0.83. We get 0.91. Now we're going to subtract. We're going to subtract 72.3 minus 5.4. It's 6.9. So all we have left to do is just divide 6.9 by 0.91. And we get 7.58 of the t-score. The next part of the question says to mark off the critical value, its opposite, and the t-score on a number line. So that's what we'll do next. To get the critical value, you'll have to go to a table called the t-table, which is actually the same table that you used last week. That table will give you the critical value. But before we can go to that table, we have to actually calculate something. We have to calculate a number that's going to tell us which row to go to in the table. So right here, we know that our sample size is 30, and right here we know our sample size is 30. So what we're going to actually have to use is a formula called df, or degrees of freedom, which is 1 less than the sample size. So all we're doing here to get these is we're subtracting each sample size by 1. So N1, which was the first sample size, was a sample size of 30 because San Jose, we had 30 people selected from San Jose. So it's 30 minus 1, or 29. To get the second number, what we're going to do is subtract N2, which is the second sample size, by 1. The Redwood City sample has 30 people. So it's 30 minus 1. Sorry, this came out right. This is supposed to be 30 minus 1. So all we've done here is we've taken the San Jose sample size, 30, and subtracted it by 1 to get 29. And we've taken the Redwood City sample size, 30, and we've subtracted it by 1 to get 29. So it's just 1 less than the first. This is 1 less than the first sample size. This is 1 less than the second sample size. Next, what we do is we have to add these together, our two answers. To get a total. So all we're going to do is take our two answers that we got here and add them. And the answer that we're going to get is 58, which is actually 2 less than the total sample size. The total sample size is 60 people, and this is just 2 less than that. So when you do this, your answer should also come out to 2 less than the total sample size. Now that we have this number, we know which row to go to in our table to get the critical value. So we need to go to the t-table. The row that we're supposed to go to is row 58, but if that's not one of the rows, you just go to the next closest one, which is 60. The closest number to 58 would be 60. And the column we're going to go to is 95% confidence. You just have to go to the bottom of the table and go to where it says 95%, and that's your column. So the column that we're using is 95%. That's the column that you'll use also, and the row that you'll use depends on which answer you get when you do these calculations. And the number where they meet up with each other is your critical value. So for me, it would be 2.0. It would be exactly 2. What I do now is I take this critical value, which I looked up, which is 2, and I mark it on a number line. Because the question asks you to mark it on the number line, so what I'm going to do is I'm going to mark off 0 in the middle. Up here, I'm going to mark my critical value, which is positive 2. The critical value that comes from the table is a positive number. Then I'm going to mark its opposite down here. The opposite of 2 is negative 2. So what I've done is I've just taken my critical value of 2, I marked it here, and I marked the opposite of the critical value down here. And I just put a negative sign in front of it, and I put 0 at the middle. Now what I need to do is I need to take my t-score and find out where it fell on this number line. And that's actually going to tell me what conclusion I'm going to reach. So this is the positive critical value. This is the negative critical value. And this area right here that starts at the positive critical value actually has a name. It's called the positive rejection region. So I put RR for rejection region. This area down here that starts at the negative critical value is our negative rejection region. And the area in between is actually just called the non-rejection region. Each of these 3 areas leads to its own conclusion. So we need to find out which area our t-score fell in so that we know what conclusion to make. The t-score that we calculated came out to let's see, 7.58, which is out here above positive 2. So this is our t-score out here, which means that we're in the positive rejection region. The next part of the question says, what is your decision about the null hypothesis? If the t-score is in one of the rejection regions, the decision is to reject the null hypothesis, which basically means you're deciding that the null hypothesis is false and that the population means are not equal. So if the t-score falls in one of the rejection regions, you reject the null hypothesis. If the t-score falls in the non-rejection region between the critical values, your decision is called fail to reject, HO, or fail to reject the null hypothesis, which means that you're giving the null hypothesis the benefit of the doubt. You're just assuming that the population means are equal and that the difference between your samples appeared by chance. The next part says, what's your final conclusion? The final conclusion depends on which of the three areas the t-score is in. If the t-score is in the negative rejection region, your conclusion is that the mean of population 1 is lower than the mean of population 2. If your t-score is in the positive rejection region, your conclusion is the mean of population 1 is higher than the mean of population 2. If your t-score is in the non-rejection region between the critical values, your conclusion is there is not enough evidence to say that there's a difference between the two populations. There's not enough evidence to say that the population means are different. So we're in the positive rejection region, so our conclusion is the mean of population 1 appears to be higher than the mean of population 2. Which in our situation would mean that we think that the mean height of San Jose is higher than the mean height of Redwood City. So we've rejected the null hypothesis. We've decided that we think that the null hypothesis is false and that there is a difference between the means of the two populations. And more specifically, we've decided that we think that the mean of San Jose is higher than the mean of Redwood City. If our t-score had ended up in the negative rejection region, we would have rejected HO, and our conclusion would have been the mean height of San Jose is lower than the mean height of Redwood City. It would have been lower instead of higher. And if our t-score had been between the two critical values in the non-rejection region, this would have been, decision would have been fail to reject H0, fail to reject the null hypothesis, and the final conclusion would have just been there isn't enough evidence to say that the mean height of San Jose is different than the mean height of Redwood City. And that's all you have to do for these three problems. You have to write out the null hypothesis and the alternative hypothesis. You have to calculate the t-score. You have to find out which row you're going to in the table to get the critical value. The row is just 2 less than the sample size. 2 less than the total sample size. Once you find out which row you need to go to in the table, you go to that row, or the closest row to it. You go to 95% confidence, and you get your critical value. You mark off the critical value and its opposite on a number line, like this. And then you find out which of the three areas the t-score that you calculated is n, and that tells you what decision to make and what your final conclusion is.